Have you ever wondered why data literacy has become such a buzzword in today's digital world? It's not just a trending topic, it's a fundamental skill that's rapidly becoming as essential as reading and writing were to previous generations. We live in an era of information overload. Every day we're bombarded with countless bytes of data, from social media posts and news articles to business reports and scientific studies. But what good is all this information if we can't understand it, interpret it, and use it to make informed decisions? That's where data literacy comes in. At its core, data literacy is the ability to read, understand, create, and communicate data as information. It's about turning raw numbers into meaningful insights. It's about looking at a spreadsheet full of data and seeing not just columns of numbers, but a story waiting to be told. But data literacy is not just for data scientists or IT professionals. It's for everyone. Whether you're a student trying to make sense of a complex research paper, a business owner looking to understand your customers better, or a public servant trying to make policy decisions based on demographic data, data literacy skills can enhance your decision-making and problem-solving capabilities. In a world where data-driven decisions are becoming the norm, data literacy is no longer a luxury. It's a necessity. It's a key skill that can give you a competitive edge, whether you're applying for a job, running a business, or simply trying to make sense of the world around you. In essence, data literacy gives you the power to navigate the sea of information that is our modern world, to separate the signal from the noise, to make sense of the complex and often confusing world of data. In this world of data, it's not about the amount of data you have, but how you utilize it. So equip yourself with the right skills, develop your data literacy, and turn the data deluge into a wellspring of opportunity and insights. Data is more than just numbers and facts. It's a language, and like any language, it has its own set of vocabulary and grammar. Let's start with some of the basic building blocks of data. Picture them as the letters and words that make up this language. First up, we have data types. These are essentially the different kinds of information that data can represent. For example, we have numerical data that represents numbers, categorical data that represents groups or categories, and ordinal data that represents ordered categories. Just like different words have different meanings, different data types provide different kinds of information. Next, we have data sets. A data set is like a paragraph or a story in the language of data. It's a collection of related data that we can analyze to draw conclusions. For instance, a data set could be a list of the heights of all the students in a class, or the sales figures for a company over the past year. Then we have variables and parameters. These are like the nouns and verbs of our data language. Variables are characteristics that can vary among individuals or objects in a data set. For instance, in a data set about a class of students, the students' heights would be a variable. Parameters, on the other hand, are numerical characteristics of a population. They're like the constants in our language. They remain the same, irrespective of the specific data set we're looking at. For instance, the average height of all humans is a parameter. Unraveling these concepts might seem like a lot to take in, but understanding them is crucial. They form the basis of how we understand, interpret, and communicate data. They're the words we use to tell stories with data and the tools we use to extract meaning from the sea of numbers and facts. So remember, data is a language, and these concepts are its building blocks. The better you understand them, the better you'll be able to speak this language and make sense of the world of data around you. Understanding these basic data concepts is the first step towards data literacy. Just as a poet needs to know different literary terms, a data analyst needs to understand various data terminologies. Let's start with big data. This term may sound intimidating, but it's quite simple. Big data refers to vast volumes of data that are so large and complex, traditional data processing applications are unable to handle them. Imagine trying to count every grain of sand on a beach. That's the scale we're talking about with big data. Next up is data mining. No, it doesn't involve pickaxes or hard hats. Data mining is the process of sorting through large data sets to identify patterns, establish relationships, and solve problems through data analysis. It's like being a detective, sifting through clues to find the hidden truths. Then we have data visualization. It's a method used to present data in a graphical or pictorial format, making complex data more understandable and usable. Think of it as translating a dense novel into a colorful comic book. It's the same story but told in a more digestible way. Lastly, let's talk about machine learning. This is a type of artificial intelligence that allows computers to learn from and make decisions or predictions based on data. It's like teaching a robot how to learn and react to new information. It's not about programming specific tasks, but rather about providing the machine with the tools to learn and adapt on its own. Each of these terms represents a crucial piece of the data analysis puzzle. They are the building blocks that help us understand, interpret, and communicate data in meaningful ways. They allow us to take raw, confusing data and transform it into valuable insights. By understanding these terms, you're not just learning jargon, you're gaining a deeper appreciation of the processes and principles at the heart of data analysis. You're learning to speak the language of data. Knowing these terminologies not only enhances your data vocabulary, but also broadens your understanding of the data world. Data analysis isn't just about crunching numbers, it's also about critical thinking and problem solving. When we talk about data analysis, it's easy to picture a data analyst knee-deep in spreadsheets, charts, and graphs, but there's more to it. A crucial part of data analysis is critical thinking. Critical thinking in data analysis is much like a detective solving a case. It's about questioning assumptions, examining evidence, identifying patterns, and drawing conclusions. It's a systematic process of evaluating data to make informed decisions. Imagine you're a data analyst looking at a set of sales data. Simply noting that sales have increased over the past 3 months isn't enough. A critical thinker would ask why. Why have sales increased? Is there a pattern? Perhaps sales always increase at this time of year, or maybe a new marketing campaign is driving the increase. By asking critical questions, you can uncover valuable insights that might otherwise remain hidden. And it's not just about asking the right questions. Critical thinking also involves evaluating the quality of data. Not all data is created equal. Some data might be inaccurate, outdated, or irrelevant. It's up to the data analyst to assess the credibility of the data and determine whether it's reliable enough to inform decision-making. Critical thinking also plays a key role in interpreting data. Once you've collected and cleaned your data, you need to make sense of it. This involves identifying trends, drawing conclusions, and making predictions. It's all about making connections between the data and the real-world implications. Moreover, critical thinking in data analysis extends to communication. It's not enough to simply understand the data. You must also be able to explain your findings to others in a clear and compelling way. This requires a deep understanding of the data and the ability to articulate complex ideas in a simple, understandable manner. Critical thinking in data analysis is like a compass in the sea of data. It directs you towards the right information. So we have taken a journey into the world of data literacy. We started by exploring why data literacy is crucial in today's data-driven society. It's not just about being able to read numbers and graphs. It's about understanding what the data is telling us and how it can influence decision-making processes. From there, we delved into basic data concepts. We discussed the importance of understanding the different types of data and how they're collected, stored, and processed. We also decoded common data terminologies, demystifying jargon to make data more accessible and less intimidating. Lastly, we examined the role of critical thinking in data analysis. We emphasized that being data literate means being able to question data, to scrutinize it, and to derive meaningful insights from it. It's about not just accepting data at face value, but digging deeper and asking the right questions. Remember, data literacy isn't a destination, it's a journey, and every step you take in understanding and interpreting data brings you closer to being a data literate individual.